we're going to do a synthesis problem with reactions of alkynes. So here the problem is synthesize trans pentene from propyne. So first step is always drawing the structures. So first propyne, so an alkyne with 3 carbon atoms. So here we have one more. That will be propyne. Then pentene, so I need to draw 5 carbons in a double bond, then 1, 2, 3, 4, and 5. So here will be double bonding 2. So if we number the carbons, remember we will go 1, 2, 3, 4, and 5. So that's trans pentene. Notice the configuration of the double bond between carbons 2 and 3. So that's that. In how a strategy to do that, let's notice changes in the skeleton of the molecule. So what we see here is that we have 3 carbons, and here we have 5, meaning we need to add 2 more carbons to the chain. So what the strategy would be is, again, similar to what we did in another problem. To add carbons to the chain, we're going to be using the fact that this hydrogen is acidic. And just to remember, it's always good to remember those pKa's. pK is 25, and we're going to be using an acid-base reaction. And again, we're going to be using, as in other examples before, sodium amide, very strong base, pKa of ammonia, its conjugate acid is 38. So capable of removing that. So the first step is forming the anion here. So removing that acidic proton will give you the acetonide anion. So the next step, we need to add 2 more carbons to the chain. So what we will be doing, so we need to use an alkyl halide to do an SN2, and it needs to have 2 carbons. So what alkyl halide is that? So ethyl bromide. So when we add ethyl bromide, then our SN2 reaction is what follows. So here, attack on the sp3 carbon. Bond breaks, electrons are assigned here. So let's just write this down. sp3, and that's an SN2 reaction. Once I have that, now I have the number of carbons that I need. So 1, 2, and 3, and then I have 2 more. So I need to make now a trans alkene from that. So let's remember there are a couple of reactions that allow us to do partial hydrogenation of alkynes, but we need to use the one that will give us the right stereochemistry. If we use, for example, Lindlar's, let me write that down. If we do a hydrogenation with a poison catalyst, which is Lindlar's, we will get the cis alkene. So let's draw it. In that case, we will have, say, metal here, and then notice that that's the cis alkene. So to get what we want over here, we need to use sodium and ammonium. So that way we complete the synthesis through the trans. And obviously, if we wanted to get the alkane, but that would be easy, right? We will simply do a complete hydrogenation, and we get pentane. All right, so different 3 hydrogenation conditions, depending what is your target molecule. So since we wanted the trans, we needed to use sodium with ammonia.